Welcome to this special topic, non-metals. So, this topic, non-metals, is going to be delivered in the following way. We're going to start with air. We're going to just to start air. Once we get done with air, we're going to take a look at hydrogen as a gas. Once we get done with hydrogen, we're going to take a look at oxygen. Then we'll move on to nitrogen. Then we'll end up with pollution, where we're going to take a look at air and water pollution, even a bit about land pollution. Let's get started. By the way, in this video, we are just going to discuss air and hydrogen. In the next video, oxygen. Then after that, nitrogen. The last one will be on pollution. So what is air? Why is it that we don't have air on the periodic table since it is a gas? So air is just a mixture of gases. So the gases that makes up air are as follows. So we have nitrogen, whose chemical formula is N2. So nitrogen makes up 79% of air. So whenever you collect air, a sample of air, or let's say you trap air in a tube, 79% of that air is going to be nitrogen. Then the second one is oxygen, whose formula is O2. So oxygen is 20%. Then carbon dioxide is third, which is 0.04%. Then noble gases, the noble gases, the group 8 elements, argon, helium, krypton. So they make about 0.93%. So among these noble gases, the main one is argon. So this is what makes up air, and that's it. There's nothing more on air. Next, we move to hydrogen. So hydrogen, these are just facts about hydrogen. Hydrogen gas exists as a diatomic molecule, H2. So there's nothing like hydrogen being H. Hydrogen gas is always a diatomic molecule. Diatomic means it is made of two atoms, two hydrogen atoms. So hydrogen is a diatomic molecule. Always, hydrogen gas is a diatomic molecule. So in nature, where can we find hydrogen? So hydrogen occurs in water. Water is made of hydrogen and oxygen as H2O. So whenever you have water, then you have some hydrogen there. It is also there in oils and natural gas. The next is, how do we prepare hydrogen? Let's say we want to have hydrogen. How do we prepare it? We know that it is in water, oils, and natural gas. But what if we want just to have hydrogen, which we want to use for some for some uses, which I'm going to share with you later. So how do we prepare? So it depends on the scale. By scale, I mean how much of hydrogen you want to produce. So there is one that you can produce just by reactions in the lab. So we say the methods that are used to produce that kind of hydrogen are called laboratory methods. Then sometimes you'd want to produce a large volume of hydrogen for industrial applications. So such we say industrial preparation of hydrogen. We're going to start with laboratory preparation of hydrogen. So in the laboratory, hydrogen gas can be prepared by reacting first a reactive metal with a dilute acid. We learned about the reaction of acids and metals in acids and bases. We also learned this fact when we were doing the periodic table on the properties of group 1, group 2, and transition metals and the likes. So this should be something that you already know. So a reactive metal with a dilute acid is going to give you hydrogen. Second, a reactive metal with water is going to give you hydrogen, though there is a catch. Remember the reactivity series. There are some metals which can participate in these reactions and give you hydrogen. Metals below hydrogen won't give you this hydrogen in the reactivity series as we discussed in metals. So reaction of reactive metal with a dilute acid. I'm just going to give you an example. This shouldn't be rocket science since we have been looking at this like forever. So zinc and hydrochloric acid are going to give you zinc chloride and hydrogen. So once you do this reaction, the gas is collected over water. So what does that mean and why is it collected over water? So one thing about hydrogen is that it is a light gas. It is less dense. Okay, so if there is hydrogen here, if you put hydrogen in water, it will go up so that it floats on top of water because it is not heavy. So this is the apparatus. So we have here where we have a thistle funnel. We are going to pour the dilute hydrochloric acid. Then we have pieces of zinc here. So they're going to react. Once they react, a gas is going to be produced. Since it's light, so it's going to go up, and because of that, it will pass through this delivery tube, and it will come here. So here there is water, and since hydrogen is not heavy, so it will float and it will be here on top. So this is the method used in the preparation of hydrogen. So just an emphasis, the method of correction is downward displacement of air or upward delivery since it is less dense. Remember downward displacement and upward delivery when we are doing preparation techniques. Okay, so upward delivery is what I've demonstrated where hydrogen moves up the water. The other method of preparing hydrogen is reaction of a reactive metal with water. Note the word reactive. The emphasis is that metals that are below hydrogen cannot participate in this reaction. So example, calcium reacts with water to produce a base or an alkaline called calcium hydroxide plus hydrogen. So this is the apparatus. So in here we have just calcium which is in water, so they'll start reacting and it will go up. Again, upward delivery. So maybe for those who have forgotten, downward displacement of air is where hydrogen is introduced where there is air. Then because of that, the air is going to go down the heavier parts of air. Then the lighter part are going to go up. The lighter part, of course, is hydrogen. But if you if I've lost you, you can just revise preparation techniques for we are not going back. So we go to industrial preparation of hydrogen. So in industry, they use the reaction of methane and steam. So methane is a hydrocarbon. A hydrocarbon is a substance made of hydrogen and carbon. So this methane, which we are going to study later when we are dealing organic chemistry, is reacted with steam. So this is the reaction. Methane, which is represented by CH4 plus water, gives us carbon monoxide and hydrogen. So this is the reaction. So for this reaction to occur, these conditions must be met. First, a catalyst should be used, and that catalyst is nickel metal. So this nickel metal should be used for this reaction to occur. Second, the temperature must be 1000 degrees Celsius. And lastly, the pressure must be, oh sorry, there's noise here, kids are playing outside. So the pressure is 50 atmospheres. So once this reaction occurs, more steam is then added and the gases are passed over a catalyst, which is iron 3 oxide. Okay, so there are two catalysts here. The first is nickel metal, which basically participates or speeds up the reaction of methane with water to produce carbon monoxide plus hydrogen. Once carbon monoxide and hydrogen are produced, more steam is fired, is added, and this once more steam is added, the gases, which are carbon monoxide and hydrogen, are passed through another catalyst called iron 3 oxide. So why is this done? So when this happens, there's a reaction which eliminates carbon monoxide and produces carbon dioxide. So when carbon monoxide and hydrogen, which have been formed in the first reaction, are passed through iron 3 oxide and more steam is added, more steam basically means water, a reaction occurs which is as follows. And the purpose of the reaction is to remove the carbon monoxide. So this is the reaction. Carbon monoxide will react with water. The hydrogen will just be a spectator. It will just be watching the reaction. So the carbon monoxide is going to react with water, the water which comes from the more steam that has been added. And by the help of the iron 3 oxide catalyst, carbon dioxide is going to be formed and more hydrogen is going to be formed. Okay, so now we have carbon dioxide and hydrogen. Then carbon dioxide is easy to eliminate. How do you eliminate it? You just dissolve it in water under pressure. Okay, then you have your hydrogen. Remember, hydrogen is not, sorry, there's noise, the kids here. All right, so so when you dissolve carbon dioxide in water under pressure, then carbon dioxide is gone, then we remain with hydrogen. Another method is what is called cracking of alkanes. So this touches a bit of organic chemistry, but no worries. So cracking is just a process by which complex hydrocarbon molecules are broken down into simpler molecules. So if we have a molecule made of carbon, hydrogen, which is so complex, is broken down into simpler forms that are easy to comprehend or to follow. So that's what cracking is. You get something complex, and that something has to be a hydrocarbon made of hydrogen and carbon, then you break it down into simpler molecules. So we go to test for hydrogen. So this is just one thing you should know about cracking. We're not going to demonstrate the entire process, but we'll deal with it later. So how do you test that? In this sample of gases, there is hydrogen. Remember, hydrogen is not in air. Okay? Yeah. So given a sample of gases, how do you know that it is hydrogen? So hydrogen gas burns with a pop sound when a burning splint is introduced to it. You get a matchstick, you burn it, then you get a tube that has the gas you're suspecting to be hydrogen. So when you put that burning splint or a burning stick, you put it on the opening of the tube. Once the gas tries to escape that tube and it meets that that burning splint, it's going to produce a pop sound like pop 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 pop. So that's the identity test for hydrogen, as it is called. So what are some of the physical properties of hydrogen? First, it has no color. You can't see hydrogen. Second, it has no smell. It is odorless. Third, it is less dense than air, like I mentioned this before. Fourth, it is not poisonous and does not support life. By supporting life is you can't breathe hydrogen. Next, we look at chemical properties of hydrogen. First, it has no effect on litmus paper. Remember the litmus paper? When we were studying acids and bases, this litmus paper was used to test if a substance is acidic or it is alkaline. So this hydrogen has no effect on litmus paper. It doesn't change the color of the litmus paper just like acids do, and it doesn't change the color of the litmus paper just like bases do. It burns in oxygen with a blue flame. So you react, you try to burn hydrogen, it's going to produce a blue flame. It is a reducing agent. It is a reducing agent. What that means is, if there is oxygen to another substance, you react that substance with hydrogen, the oxygen is going to be taken away. Remember, reduction or being a reducing agent is having the capability to take away oxygen from a compound. So to be specific, it reduces the oxides of metals. Oxides of metals are like calcium oxide, potassium oxide. So it reduces the oxides of metals below it in the reactivity series. So on the reactivity series, there are those metals like gold, silver, which are below hydrogen. So those oxides are reduced by hydrogen. The oxygen from the oxides of gold, silver are taken away by hydrogen, but not the oxides of metals above hydrogen, which are more reactive, such as calcium and potassium. So what are some of the uses of hydrogen gas? First, it is used in the manufacture of ammonia in a process called Haber process, a process we're going to study when we are studying nitrogen. Second, it is used in the manufacture of margarine, or is it margarine, from vegetable oil in the process called catalytic hydrogenation. So there's a process called catalytic hydrogenation, which we're going to study also when we're dealing with organic chemistry. So hydrogen is used in that process. Liquid hydrogen is used as a fuel in rockets. And finally, it is used as a reducing agent. So this marks the end of this part of nonmetals, where we have discussed air and hydrogen. In the next video, we're going to take a look at oxygen. Happy solving!